Hi guys, in this video what we're going to do is going to talk about the intersection of a line and a circle. So when we have a circle and a line, there's three possible results that could happen. So you can see here's a circle and here's three different lines. So if we look at the first line, that's going through the circle twice and you're going to get 2 points. Okay, so where it intersects the circle. So it intersects A and it intersects at B. And this is called the secant of the circle, and the segment AB is called a chord. You should know that from geometry. Okay, the second thing that can happen is it can just go by and just touches the edge of the circle, and it touches it once instead of the twice, which is this line here. And that means it's going to make a tangent with the circle. So it just kisses it at one point on this circle here. And the third one here, line 3, that's when it doesn't intersect the circle, it's on the outside, it doesn't touch. This means for the first one, i.e. 2 points, we'll get two solutions, so two answers. Okay, for the 1 point, which is the tangent, we're going to get one solution or one answer. And for no points, then there's going to be no solutions, i.e. no answers are going to happen. It's never going to cross. Okay, so let's have a look. It says find the points of intersection of the line x minus 3y plus 5 is equal to 0 and the circle x squared plus y squared minus 6x minus 2y plus 5 is equal to 0 is the line of tangent. Give a reason. Okay, so what we have here is equation 1, we know is x minus 3y plus 5 is equal to 0, and equation 2 is x squared plus y squared minus 6x minus 2y plus 5 is equal to 0. Now I'm sure you've noticed that what we have is we have two equations, we have two unknowns, the x's and the y's, so this is a pair of simultaneous equations, and this is the type of linear and non-linear. So first thing is to work out which one's the linear, and it's the top one. So this one here is the linear equation, this is the non-linear because it's a circle. Okay, so first thing we do is we have to rearrange the linear equations so we get x is equal to something or y is equal to something. So let's have a look at that. We've got x minus 3y plus 5 is equal to 0. Hopefully you can see I can take the 3y and the 5 across, and I'll get x now is equal to, I'm going to get 3y minus 5. That means I can now eliminate the x by sticking this x in for everywhere I see an x in this non-linear bit, and what we're going to end up with now is x squared, so that's 3y minus 5 all squared, plus y squared minus 6 lots of 3y minus 5 minus 2y plus 5 is equal to 0. So just very quickly, you can see x here, x squared, so x now is 3y minus 5 all squared, plus the y squared, minus 6x, so minus 6x gets changed to 3y minus 5, minus the 2y, plus the 5 is equal to 0. We now have an equation that's all in terms of one variable. We've got rid of the x, so we're going to end up now with a quadratic in terms of y, and we can solve that, hopefully. So we're going to multiply out this bracket. So if we do that, we're going to get 9y squared minus 30y plus 25 plus the y squared, and we've got this minus 6 by 3y, and minus 6 times 5, so minus 6 by 3y is minus 18y, minus 6 times minus 5 is positive 30, minus 2y plus 5 is equal to 0. I'm going to collect the y squares, the y's all together, and the numbers, so we're going to end up with 10y squared minus 30y minus another 18 is minus 48, so that's minus 50y. And then we've got 25 plus 30 plus 5, so that's going to be plus 60 is equal to 0. Now, hopefully you can see there's a common factor here, that we've got 10, so we're going to divide both sides by 10, which means that we're going to get y squared minus 5y plus 6 is equal to 0. And now what we need to do is to factorise this. Okay, so y is equal to 0, and hopefully you can see this is going to be minus 3 minus 2. Just double check it. Y by y is y squared. Minus 3 times minus 2 is positive 6. Minus 3y minus another 2y is minus 5y, so that works. And we're going to get two answers of y is equal to 3 or y is equal to 2. Now I'm not quite finished because I should really work out my x coordinates. It doesn't really ask me in the question, but I should do it anyway. So my x coordinates here, I can stick these y values into this here. So if I put the first one in, so when y is equal to 3, x is equal to, and it's going to be 3 times 3, which is 9, 9 take away 4, 5, sorry, which is 4, so x is equal to 4. So the first one is 4, 3. And for this one here, when x is equal, y is equal to 2, sorry, x is equal to, putting it into this, 3 times 2, which is 6, 6 take away 5, which is 1, so x is equal to 1. So the second coordinate is 1, 2. Now, remember if we go back to the first slide, it said if it goes through twice, you're going to get 2 points. You can see here that this definitely goes through twice. We've got 2 answers, which means that this is not a tangent, because a tangent would only go through once, which means that what would have happened, we would have had, this would have been the same answer. For example, y is equal to 3, y is equal to 3. Because it isn't, and we have 2 distinct or different coordinates here, that means that this is not a tangent. So just to finish this off, not a tangent. And we are now done for this example. Okay, let's have a look at another example. So it says here, motorway represented by the y-axis crosses a large circular reservoir whose equation is given by that expression there, or that equation there, at the points A and B. The units are in kilometres. It says find the coordinates of A and B. Okay, so let's have a look at that for that first one. We'll try and find those coordinates of A and B, and we know that it's the y-axis, and at the y-axis we know that the x value is equal to 0, because we've not gone across left or right. So that means that we can substitute in 0 into the equation of this equation here, and we should be able to then get these 2 values at which it crosses the circle. Okay, so let's have a look. So 0 squared is 0, plus y squared, minus 6 by 0, which is 0, minus 14y, plus 33 is equal to 0. We end up with y squared, minus 14y, plus 33 is equal to 0, and it's just a case of solving this quadratic. So here we go. We get y minus 11, y minus 3. Okay, and if we just double check that again, so y by y is y squared, minus 11y, minus another 3y is minus 14y, minus 11 times by minus 3 is plus 33. So y is equal to 11, or y is equal to 3. So there's the 2 coordinates that we have here now. So remember, for both of these y values, our x value is equal to 0 because it's on the y-axis, i.e. this axis here. So I'm just going to put them on the diagram. We'll probably need it later. So this one here is 0, 3 at A, and this one here is 0, 11. Okay, so there it is. Okay, the next thing it asks us to do is to find the length of AB. Well, that shouldn't be too difficult. You can see here, it's basically going from 0, 11 down to 0, 3. So that's just 8 units. So for this one, it's simply 11 minus 3, which is equal to 8, and it's kilometres in this case. Okay, part 3. If another motorway is represented by the x-axis, show that this motorway does not intersect the reservoir. Okay, so if the x-axis is being used here, we're going to do pretty much what we did last time. What we did here, we said that the y-axis x is equal to 0, which means that the opposite is true. If it goes through the x-axis, then that would imply that y must be equal to 0. Okay, so that would imply that that's true. So we're going to do what we did before. We're going to go back up to this equation, and wherever we see a y, we're going to put 0 in and try and solve for x this time instead of solving for y. So what we now have is x squared minus 0 minus 6x minus 14 by 0, which is just 0, plus 33 is equal to 0. So we're not sure where that comes from. It's going up to here. Wherever we see a y, we're going to stick 0. So we're going to x squared plus 0 minus 6x minus 14 by 0, which is 0, plus 33 is equal to 0. Okay, work it through. So we've got x squared minus 6x plus 33 is equal to 0. And what we're going to try and do now is going to try and solve that. I can't see any factors on this. So if there's no factors, what we're going to do is we're going to use the minus b formula, okay, the quadratic formula. So x is equal to minus b plus or minus b squared minus 4ac all over 2a. And if you can't remember which one's which, remember it comes with the form ax squared plus bx plus c. So for this one, my a is equal to 1, my b is equal to minus 6, and my c is equal to 33. And stick these numbers in. So we've got x is equal to minus 6, which is just 6, plus or minus. We've got minus 6 all squared, minus 4 by a, which is 1, by c, which is 33, all over 2 by 1. Okay, let's keep going. So we've got x equal to 6 plus or minus, and we've got minus 6 squared, which is 36. 36 minus all of this is going to be, if you stick it in your calculator, it comes out to be minus 96, and that's all over 2. And now we have an issue. Because if you have a look at your square root here, you can see here that we have a minus 96, and if you put the square root of minus 96 into your calculator will give you an error. It doesn't like it. And the reason it doesn't like it is because there's no real value for this as an answer. If there's no real value, that means, in this particular case, that the circle does not go through, or the x-axis does not go through the circle. Okay, so what's happening if I draw this on the diagram is the x-axis, I'm going to draw this in green, is actually underneath here. And it's going past it, it's not actually touching. So if it is not touching the circle at all, that means that you will not be able to find any real roots for your quadratic equation. So what we have here is no real roots. That implies motorway does not intersect the circle. Okay, the last thing is if we are given an equation of the circle and an equation of a line, and we want to know if it's a tangent to C. The two ways of doing it. The first one is what we've just done there, is we can try and solve them simultaneously, and if we do that, we'll find that we're going to get a repeated root. The second way to do this, this is actually easier, is the perpendicular distance. So what we do from the equation of the circle, we can calculate the centre and the radius. So from here, for example, on this, we can get we can calculate the centre and the radius of this, and then what we can use is the perpendicular distance formula to see if the radius is equal to the distance from the line to the centre. Okay, so if that's the case, then it's a tangent. If it's not the same, so if r is not equal to d in this case, then it is not a tangent. It's either further out or it's closer. Okay, so let's have a look here. So determine if the line 4x minus 3y is equal to 31 is a tangent to the circle. X squared plus y squared minus 6x minus 4y minus 12 is equal to 0. So the first thing we need to do is work out the centre. So the centre of that circle, remember, all we do to get the centre, halve it, change the sign, halve it, change the sign. So minus 6 halved is minus 3, change the sign, gets you to 3. Minus 4 halved is minus 2, change the sign, you get 2. And then r is equal to the square root of g squared plus f squared minus c. So r is equal to g squared, which is 3 squared, plus f squared, which is 2 squared. And we've got minus 12, don't forget the double negative there, so that becomes plus 12. Okay, and if you work that out, r is equal to 9 plus 4 is 13 plus 12, which is 25, so root 25, which means r is equal to 5. We're now going to work out the perpendicular distance from the centre, which we know is 3, 2. And we also know that this line is 4x minus 3y minus 31 is equal to 0. Notice, remember, in order to use the perpendicular distance formula, you need to have it of the form ax plus by plus some constant is equal to 0. That's why what we had to do here was bring the 31 across to this side here from here. Okay, the perpendicular distance formula is given by d is equal to ax1 plus by1 plus c modularized all over a squared plus b squared square rooted. And remember, we've already labelled here. You can see that we've got A is 4, B is -3, C is -31 here, and my x1, y1 is the centre of the circle. So I'll just quickly label them now. That there is x1, that there is y1. Just a case now of throwing the values in and seeing what happens. So D is equal to the modulus of A, which is 4, by x1, which is 3, plus B, which is -3, by y1, which is 2, plus C, which is -31, so plus -31 in this case. That's going to be modularised all over, and it's going to be 4 squared plus A squared plus -3 all squared, and that's going to be square rooted. Let's do the top. D is equal to 12 minus 6, which is 6 minus 31, which is -25. Don't forget we've got to modulise that in a second. And 4 squared plus -3 squared is 25, so you end up with the root 25 on the bottom. D now is equal to, you can see the -25 is going to change to +25 because we're going to take the modulus, and then root 25 is 5, and D is equal to 5. Now, as the distance from this tangent to this point is the same as the radius of the circle, which we've worked out from here, this means that this is a tangent. So as D is equal to R, this implies tangent. If D was greater than R, then it would be over here somewhere. If D was less than R, it would be inside the circle here. And that's it, boys.